Hello guys, I'm back again and I'm Kelvin Gibson. This is another video and it's just a continuation of the previous video. Remember, in the previous video we explore on how to perform a simple linear regression using Python, and we used two packages for Python, and it was Start Models and Sklearn. In this case now, it's more of mathematics, and we're doing this so that we can understand and interpret simple linear regression outputs. We're actually doing with Microsoft Excel. So it is tedious and time consuming computing linear regression model by hands. Henceforth, there are some softwares that speed these tasks, such as Microsoft Excel. Microsoft Excel has add-ins such as Toolpack and Regressit. There's some other software such as SPSS, Starter, Minisub, Air, and Python programming. Remember last time, however, as a statistician, data scientist, data analyst, and mathematician, you need to understand what and how each and every computation is happening behind every regression output displayed. Therefore, Microsoft Excel, just like Python programming, provide the best platform to build a model and use it with a various and different dataset. This is like building another software in a way that you prefer. In this video, we are going to build a simple linear regression model with Microsoft Excel, and we will use the dataset with 25 rows. Now, I want to predict the sales based on the number of the TV shows in the advertising. This is the marketing dataset, and we want to predict the sales based on the TV shows. So here, let's get started. So in this Excel sheet, this is what we're going to prepare. This is a model, and we will just fill all these gaps. So here, this is our input data. Over here, we'll put independent variable, of which is the number of TV shows, and here dependent variable, which will be the sales. So this is the other columns will be the addition columns, which will help us to calculate some computations, some simple linear regression formulas. So there are some steps which we will follow as we are building this model. And the first step is to calculate mean, and the step 2 is to build model. Step 3 is we'll calculate errors, then the statistics. Then here we will build another table, and here these are the fifth step, the evaluation, and we will able to evaluate it in two ways. We'll calculate R squared and adjusted squared, and the last step here we will calculate mean square error, mean absolute error, root mean square, all those evaluation method. So also here, this is another step where we will be required to build an interval of the intercept or coefficient. So now let's get started. So here I have two workbook, and I'll go to this model data, then I'll copy, I'll highlight, Control C to copy, then move back where we were, and then highlight all of this, then Control V to paste. That's way. So here I'll just apply apply the format then so that it's yellow. Yeah, this way. Or here, so I'll have to control that to redo. It can also remain this way, but it doesn't look nicer. So I'll try again and come and ensure it's exactly here. Then clear. Now it's okay. So here, let's start building our model. So we will build this model. Then we have it's like a software, just like I've said, and I have another data set here which I will test whether the model is working well. So let's get started. Let's go back to our simple linear regression model. So there are some addition columns which we need to add, and these addition columns, the first one is x. Let me resize increase so that to be visible. So here the first one will be x squared. This x squared, remember our independent variable is a TV shows, and it is our independent variable. It tries to explain our predict our response variable of which it cells. So I will just increase the size a little bit so that we can see. Oh, I can increase the size. Yeah, so here I'll just put equal sign, then put my cursor here, then I can square it, then hit enter, then I can drag down to fail downward this way. Then the next one, can resize this a little bit. The next one is y, our y squared, which is our dependent variable or response variable. This way, also expand a little bit so that it will be visible. Yeah, response variable of which it cells. So I will just increase the size a little bit so that we can see. Oh, I can increase the size. Yeah, so here I'll just put equal sign, then put my cursor here, then I can square it, then hit enter, then I can drag down to fail downward this way. Then the next one, can resize this a little bit. The next one is y, our y squared, which is our dependent variable or response variable. This way, also expand a little bit so that it will be visible. Yeah, this way. So I'll just put equal sign, and then I will squared, then I'll drag down to apply and ensure it matches. Click here, it's okay now. The next column is I will multiply my x and y here. Then I'm multiplying independent variable times dependent variable. Hit enter. Then I drag down until it matches. So what I want to show you is that I have some formulas which it's need those additional columns, and this is the formula for simple linear regression, this one, and the formula for intercept is coefficient of intercept is this one, and there is two method for coefficient of slope. First method is this one, and second method is this one. Yeah. So, but before we calculate the coefficient of intercept, we must first calculate the slope coefficient, and we will use both of these methods, and you will able to see that it result to the same answer. Now, since this beta 1 estimate will come from this formula, we have to find the slope coefficient first. Then later we will compute the slope coefficient, and then finally we will build this model. Let's continue back in Excel. Let's go back to the Excel and continue. So we are adding columns that will help us to use the formula that I have shown you. Okay, now here what we need next, uh, we need this from X, where we need to have this column whereby it's mean of independent variable minus observation of independent variable times mean of dependent variable minus independent variable observations. I need to resize, oh, it's okay. Yeah, I need to resize a little bit here so that it will fit. Next, I need to find this one, this column, whereby it will be mean of independent variable minus observations of independent variable. So after that, we'll first compute this, the other will follow. So let's continue. So before, remember the first step was to compute the mean of dependent variable and independent variable. So here we'll come to this cell where to return x mean, then we'll use the formula average, not the average is the first one. Then I'll highlight this first range. Since it's x mean, it means mean of independent variable. I'll highlight all the end here. Then I'll close parenthesis, but not the end. You leave the last row so that you can compute the totals. So then I'll hit enter, and there we find that we have found the mean of the independent variable. Next, mean of, we also use average to find the mean of dependent variable, and here it is. Then I close parenthesis, I hit enter, and here I found the mean of dependent variable. Next, I want to find the number of observations. You can either use the number of dependent variable of independent variable. After all, they are all the same. They have the same dimension. So I'll use the formula, exact formula called counter, equal sign counter. This formula count everything within the cells. I'll just start from here. I remember you leave the last row so that we'll compute the total. So I use the independent variable values. You can either use either of the two. Then I close the parenthesis and then hit enter, and I have 25 observations. So now first step, we have done with the first step. Let's continue building our model. Now we are going to step 2. Step 2 now, I have to increase this so that it's visible. Yeah. Step 2 now, what we need to do in step 2, or here want to take it, yeah, that's it. Now in step 2, move it back, yeah. So now remember we want to compute the slope coefficient. Just as I've said earlier, this is what we are starting with. Then it will give us the way forward, and this is the formula. We can use both of this formula and you will see that we have the two results. Okay, let's continue. So now here we want a numerator. Numerator, as the formula is showing above, numerator is equals to number of observations n times sum of, but there is something that I've not had done. This one is for total. I should delete this 0, control D. Yeah, that's right. This is for total. So here I'll hit alt equal, then I'm summing. The next one, next cell, alt equal sign and hit enter. The next one, alt equal sign. Oh, this one is not working because these two cells are so close. So I'll put equal sign sum, then the above rows from here, from just above. Then I'll close the parentheses, then I hit enter. What am I remaining with? I am remaining with two more. Yeah. So equal sign sum. Then I'm highlighting just above this cell till here where the column names are. Then I will hit enter. Then this one also equal sign sum. Then I'm taking this sum range. Oh, something should start from here, just above that cell, then till here, below. Yeah, then close the parenthesis, hit enter. Yeah, something. Sim this. Oh, we didn't compute. So it's okay. Equal sign sum. Then I'll write this one till here. Then close parenthesis. Hit enter. Now, if we put any values here, then it will be computed. It will be sum or computed automatically. So now let's follow this formula. X bar. So X bar, we want to use X bar, independent mean, to subtract every observations of independent variable here. But to avoid this mean from moving, we have to lock it with $sign. Lock the letter with $sign this way. Then I hit enter. But we have to multiply both of them. Mean of independent variable times mean of dependent variable. In this case is this one. We are subtracting the dependent variable observations, just like we did to mean of independent variable. We are also looking this mean of dependent variable. That way, then if I hit int, if I hit enter, then I drag down to fill and ensure it's matched. Then if I click the last one to ensure it's follow the same formula, you can see that this one, these two are highlighted, means the cells didn't move. Yeah, so this is how we, even here, but these two move, but this one below didn't move because they are means, and I lock them to ensure it's not moving. So this has been computed automatically. Now we are ready to go. Let's put it here. Let's sum this one. Alter equals sum the first column. Hit enter. The second one, hit alt equals sign, then hit enter. And we have to format it nicely by putting it in a table, putting them on a table. I'll hit, after selecting, I'm going to hit alt H B then A for, then you format it nicely. Okay, let's continue. Now we are on a safe place to use the formula. We're in a right track actually. So here, what I'm going to do, I want to use the first formula, and the first formula is, so we we have we have to find the numerator. Remember, this is the numerator, but we are starting with method 2. So in this method 2, we'll find first the numerator, then denominator. Let's go back to the Excel workbook here. So now our formula matters first. I have to start it. So what we are actually doing, we gone wrong here. Yeah, suppose here we gone wrong here. So multiplication of this, where we go wrong here. We did multiply here. Well, yeah, this where we go wrong. It should be x times y. That way. Then drag down until it matches. Just add another column here. Yeah, I'm sure we'll get correct now. So here, just we are multiplying. Let's open parenthesis. Number of observations, which is 25, times this column xy minus sum of x squared times sum of y squared. And if I hit enter, we are getting the right answer. I'm sorry for what I've done in this fifth column. Okay, let's continue. Then denominator. Here in the denominator, we are supposed to take number of observations times sum of x squared, of which it's the third column. Then I multiply with the I'm subtracting with multiple of x, sum of x squared. is the sum, then I have to square it that way. Then I'm getting 382. Now we are in the right track. This is the correct answer. Now we are in position now to divide. So numerator over denominator F47 47, and we are getting intercept value of 9.77. Now we have just calculated base estimate using the method 2. Now let's go to method 1. Let's go back to the Excel here. Method 2 now. I exchange this in the other PDF. It's method 2, but this one now it's method 2. So now let's go to the another method. Base method. In this method, we are taking these sixth column. 1, 2, 3, 4, 5. No, should be. Yeah, should be. No, I just forget. I forgot to compute this one, but okay. So I'm taking the third square here. Here's a square. There's a square here. Yeah, that's right. So here I'll take observation of independent variable minus, or I can even take mean. It's either of the way around. It's okay since we are squaring the final answer. So x minus observations, of which it's t independent variable. Then I wrap with parentheses, then I square, then I'll drag down to fill down. That's right. Now we are ready to use method 2. So here in method 2, no, not there. Method 2 I left here. So in method 2, since we have these columns, I go to this column, totals, sums, then here, then I divide with the last, this one, and these are the columns names. I divide this one by this one, then what I'm getting. If I hit enter, then you can see, oh, they're not the same. I wonder why. There's something that I've done wrong. B1, method 2, B1 we get 9, but this one we didn't get that one. So there is something wrong. Oh, I didn't lock the mean. That's why. So this the first cell, I didn't lock the mean here. Then if I hit enter, then I drag down here until where it matches. Then we receive the same answer. Yeah, wow, we are getting the same answer. Next, now we are in position to get a B slope intercept coefficient of slope using this formula. Now it's equals to mean of dependent variable plus, or it should be minus, I guess. I think I make an error here. Yeah, it should be subtraction. Sorry, correct that formula. So here, equal sign y bar, which is the mean of dependent variable, we are subtracting what we got here, b1 as coefficient of upslope times mean of independent variable, which is here x mean. Then I hit enter. Then we are getting the coefficient of slope. Now here you can see this one is automatically computed. So I have to copy this one and paste here. That way. Now our model is ready, and you can see we have started from calculating the coefficient of slope, followed by coefficient of intercept, and finally we have our model as this one. Okay, but I want you to remember that we have made correction, and this formula here should be subtraction instead of addition. So let's move back to the model worksheet Excel and continue calculating, moving to the next step. So we want to move to step 3, but before we move to the step 3, there is column. We will need to add columns for predicted or fitted values of the model equals to, oh, what did I got as intercept, YH equals to 2.484 plus 9.776x, which it is dependent variable. Now, having the fitted values shown, having that of fitted values, we are ready now to compute the residual. Now let's first replace those values. So 204.8548.5 is a slope plus 9.776, the slope coefficient, times x, our independent variable here. Now this one. Then I'll hit enter, getting 26 as a predicted values. What was the actual? Actual was 21. Yeah, you can see there is some difference, though it's not that much. Then I will drag down to fill these ones. Yeah, so this one is 78, and this one, and the real value was 86. There's some deviations, but this how model works. Next, we want to compute the residual. Residual is simply the difference between the fitted values and the observations. So residuals E equals to, I better put it in absolute, observations. Oh, Y is equals to difference between observations and fitted values. That's why Y hats. It's the same as this YH. Yeah. In fact, I should put it this way to looks the same. Yeah. That's way. So here I go. I will use dependent variable to subtract the estimated values here. And since we are dealing with absolute, I'll use Excel formula ABS. which will eliminate the direction of the values. It will neither be minus nor plus, yeah. So then I drag down to fill, and if I click the last one to see if it's applied, it's okay now. Now this is the residue. Next, I also need to add in this last column here, alt equals sign, no, control Z. I'll select this range this way, but I should put a range from just above this cell of sum, then hit enter. Then also here I'll sum the next column from just above here until here, then I'll click. I also need to format this way, these totals, alt HB all, then I'll just format it nicely, and I should put it in a bold, control B, and increase the font here, yeah, then it's look nicer. So we have just calculated the residue. The next, we want to prepare another table, and we will need SSE, SSR, and SST. So SSE is sum of square of error, and it means the difference between the fitted values and the and dependent variable observations. And here the formula goes as observations, I shall put small I, minus or just y, minus predicted values yh, then squared. Then that's formula for sum of square of error, or sum of square of residual in any language. Then sum of square of regression, or it's also called sum of square of the model, is equals to independent variable observations minus mean of dependent variable, mean of dependent variable, then I square. And the next one is the next one is the difference between the dependent variable observation and the mean, yeah. So here I've just here this wrong, sorry. So here should be predicted values or fitted values minus the subtracting the mean, and here should be observations minus predicted minus mean. I'm sorry, it should be this way, yeah, minus mean. Since is, yeah. Also SST is calculated in this way, SSE plus SST, sum of square of error plus sum of square of model. Don't know why I'm doing errors every now and then. Yeah, so we'll see these two formulas and it will give us the same result. Okay, let's now compute the sum of square of error. I just go to the dependent variable. Then I subtract. I'm subtracting. I'm subtracting estimates here. Then I wrap with parentheses. I'm wrapping with parentheses. Then I'm squaring and hit enter. Then if I drag down here, and here, remember to put some that way. I should put lowercase one. That's way. Then adjust these cells so that it will be visible. So here I'll add some because we need here. But so yeah, just here should add here squared. But so it's okay now. Okay. Then I'll move to the next one. I'll calculate y estimate based on subtracting the mean, and I must, or you should remember to lock the mean to avoid the area that's to avoid the error that I had before. So here I'm locking this self of with the mean value to avoid it from moving. Then I'm wrapping with parentheses. Then I'm squaring. That's way. Then if I hit enter, it gives me a result. Then I will drag down to fill. Drag to fill. That way. And we are in the right path. Just increase this font. Okay, now let's find SST. These are simply the difference between the observations cells of dependent variable and the mean B44. Mean is B44. Yeah, mean of dependent variable. Then I hit enter, but it's still unfinished. I'll just wrap with the just lock with a dollar sign here. Locking with the dollar sign here. Then I wrap with parentheses. Then I squared. Then I hit enter. And if I drag to fill down, all values will be computed that way. Yeah. Now we have done another formula that I want to confirm. I'll take SSE, but I have first to add here. I need to add the total of these rows. I'll just put sum equal sum. Then I'll sum from here till the where the column names are. Then I think I should drag to the right side, and of course some all the rows have been computed. Then I'll highlight, then I'll hit Alt, then H, B, then O, create a table. Now we are almost done filling these columns. The next one, oh yeah, so in fact I'm done. I simply want to confirm whether it gets 15,000 for the sum of square total by adding sum of square error here. and sum of square of regression. And let's see what we are getting. 15/4. In fact, the same result is achieved from the two different methods. Okay, let's move to the next step. Now we are in step 3. In step 3, we want to compute the errors. And the errors, we compute the errors for a model, then an error for intercept, and then errors for coefficient of slope. So let's first begin with the errors for the model. So here in the model, here suppose the formula is SSE over n over 2, just like the way it's being shown here in the PDF. And here we know our n is the number of observations, and SSE is what we have just computed right away here. So we are just taking we are just linking the values or taking the values from the table here. So now let's do that. Okay, so this is the SSE, divide, open parenthesis. The number of observations was n was 25, but I'm supposed to subtract 2 just as formula instructs me. Then I hit enter and I'm getting 31 errors of the model. Next, I want to find the errors for, oh no, before that, I need to find the standard error. This is the variance. What we have just calculated right away is the variance. Now we are in the standard error. So I'll just take root of the what we have calculated above this cell, and if I hit enter, I'm getting 5.6. But it's okay. Let's now continue. Now we want to calculate or find the standard error of intercept. From the formula here, the formula for standard error for intercept coefficient is this one. But before, I've already seen the errors, and these are second denominator. This is the first denominator n, and this one is second. In this one, I should squared it. We should squared the denominator of this second. These xi observations minus x bar. We should take the square of this denominator. I'm sorry about this one, but we'll see how we want to work here. Okay, so here the formula instructs us that the first thing we should take is use square root formula sqrt from Excel. Then we here here should be s squared, where this asterisk is should be s squared. Then s squared is what we have computed this first, this cell. Then we are multiplying. Let's open parenthesis. Let's open again. 1 over observation. In our case it is 25. We are linking. Then I'm supposed to add I'm supposed to add should not multiply just as I've written here. I'm supposed to add, let's see the formula here. I'm supposed to add x bar squared here, x bar squared here, x bar squared divide this column, this as xx. Where is this xx? This xx, yeah, this one. I should take this to sum of this one. Then I go back here. Then I closed here and I closed here, and then I'm closing here. Yeah, yeah. So if I hit enter, it's an error of, yeah, I should get 2.5. No, should not get 1.5. Should be getting 1.5. What's going wrong? So I'm multiplying this one times y. I should this with parentheses. Also grab this, yeah, this way. I hit enter, getting 1.5, and I should not be getting 1.5. Let's want to see where the error is. I want to see where the problem is. Where the problem must be. Oh, yeah, there is a problem here. I divide with SSE instead of SXX. Where is this XX? Where is it here? Should here. It's here in this, right? No, this one. And I'm getting, yeah, now we are okay. I'm getting the value of 2.5. These are very okay. So in this formula, let me edit. Here should be power 2, and here should be x squared. Yeah, that's way. And here where it's static is where I'm multiplying should be plus. That way. That's how formula should be. So the next thing I want to calculate the slope of the coefficient of the slope, and this one is not hard, just like the way we have calculated the coefficient of intercept. So here, yes, we simply required to just take the roots of variance and multiply with square roots of the column that this column that we are looking earlier. Oh my, where am I? I'm supposed to erase this one. I'm supposed to divide with SXX, and SXX is here. And if I hit enter, this is what I'm getting. I'm getting 0.45, and that's very correct. Now let's go on. Now we have done computing the errors. The next thing we are required to do is to calculate the t statistics. So the t statistics, it's simply dividing the estimate of intercept of coefficient of intercept divided by its corresponding error. This also applied to the coefficient of the slope. So the formula is here. The formula is here. Here is that coefficient of intercept over standard error of intercept. The next one also coefficient of beta 1 estimate over standard error of beta 1 estimate. So let's go back to the Excel workbook and calculate it. So here we are simply taking this coefficient of intercept. Just come to the intercept here. Then I divide with standard error of coefficient of intercept. Where is it? It's here, 2.5. And I'm getting t statistics of 0.98. The next one we are doing the same intercept coefficient of slope, here, and I'm dividing standard error of coefficient of slope just about here, and I'm getting this one. So that's how easy it is. Next we are required to calculate the p-values. So in p-values we will use Excel formula called t dot dist dot 2t here, and this one I take two arguments. This one takes two arguments, and the first argument is the p-value here, and observations, number of observation, subtracting 1, and we are subtracting 1 from the number of observations, and we are getting 0.33 for p-value for coefficient of intercept. Okay, next we're doing the same. The formula is t dot dist dot 2t. Also we are taking the t statistics, and the number we are taking 1 away from the number of observations. Here, then we are closing parentheses, and if I hit enter, we are getting 0.0. That's how we are dealing with this step 3. Next, what we need is to build an over table. An over table, we require to compute sum of square due to ratio due to regression model, sum of square due to error, and sum of square total. But here about the columns that we computed, we will just extract the values from these columns totals here. It will be so easy. So now, once you have built that table correctly, we are on a safer hands now. So let's start. Sum of square due to regression or explain variance. Sum of square, it's a variance which can be explained by the model. So here I'm simply linking sum of square due to regression. I will simply link to this value SSR, and it's here. Then next one is SSE. I'll just link with SSE here, total here, and the next one I link with SST, and it's the last column, and hit enter. Now we have extracted those values, and here are they. Next one, we want to find the degree of freedom. Degree of freedom for sum of square of regression is simply number of regressors minus 1. In our case now we have a single regressors plus two regressors plus the coefficient of intersect, and we are subtracting only one regressor that we are having. So here it will be regressor equals to k minus 1, k minus 1, and it will be 2 minus 1, 2 regressors minus 1. Then put here equal sign, and if I hit enter, we are seeing regressors is equals to k in a minus 1, and we're having only one. And degree of freedom for sum of square error is simply the number of observations we are subtracting the number of regressors, and in our case now we're having two regressors. So it will be n minus 1 equals to number of observations minus number of regressors, of which it's 2, and we're having 23. Okay, the degree of freedom for sum of square of total equals to number of observations, of which is 25, and minus 1 equals to 25. We should put dollar sign here above after 25 minus 1. We're only subtracting 1, and here we're getting 24. Okay, now it's time to find mean square of error. Mean square of regression, it's simply we are taking sum of square due to regression divided by this value here, 1. That's why we divide by degree of freedom for sum of square due to regression. The next one we are doing the same, sum of square due to error over degree of freedom of error, of which now in this case now it's 25. This is we better link this way, minus 1, then we close with brackets here, and if I hit enter, we are getting it's 30, and I think should be 31. Oh, it's something. What should I get here? 722. Yeah, we are in the right track. Now we need to find F statistics. F statistics is we are taking the sum of mean square error, mean square of regression divided by mean square of error. So we are getting F statistics of 486. But I think there is where we have made an error. Somewhere we have made error, a little bit of error. So here it should be 14624 0.76, and here should be 30. Should be 31. Here should be here 72.0681, and if we divide here should subtract the 2. I'm sorry, that's where I've gone wrong. Yeah, we subtracted 2. Yeah, the 2 and divided by 2. So now, yeah, it should be 465. I subtracted 1 here instead of 2. Okay, now we are incorrect. Now, to find the p-value, remember these values are usually calculated from the table, F table, but now it's called F critical or F table. But in our case, Excel has a powerful function called f.list, and this one take 3 arguments, and the first one is the degree of freedom. Is this F statistics value, degree of freedom of model, of which now in our case now it's 1, and the other one is degree of freedom of sum of square of error, subtracting 2, and it goes. I should wrap with parentheses. This one I should wrap with parentheses. This one. F statistics. Oh, it takes only 2 arguments. It should be 1. F dot list. Check these statistics. Then degree of freedom 23. Then 1. Then 1. Okay. So here I should use 25 minus 2. Degree of freedom for mean square error. And I'm getting 0 point. But it seems that I've extended distance. Should put 1 here. Degree of freedom 0 point. Yeah, this way it's looking nicer. So next, what we are supposed to do, we are supposed now to, now we have done creating another table, and now it's here, and we have created it very nice. Can zoom so that you can see. Now this is the another table. You can run this regression model with another software, and I'm sure it will match. Okay, now let's continue. This step 4. Let's go to step 5. In step 5 here, in step 5, it's very easy. And you're required to build R squared. Remember, R squared is the how independent variable can explain the dependent variable. That's what R squared means. But adjusted R squared, it penalizes the model by any addition of independent variable which does not explain the dependent variable. So here, the formula for independent variable, just as being shown here, is equals to 1 minus SSE. Where is the SSE? I think it's here. SSE over SST. Then we have to wrap it with brackets. this way, and it's okay. Then if I hit enter, now we are having our r squared. Another alternative way is just to use SSR over SST, and we are going to do it right now. So SSR here is the second last column divided by this last column here, and we are getting, I hope we're getting the same answer. And of course this this what we're getting here, and it's the same. So let's calculate the adjusted r squared. Adjusted r squared is simply you done by taking this formula. I'm sorry, I forgot to show you this PDF. We are here in evaluation. There is something that's I did it. Numerator degree of freedom, denominator of degree of freedom here. So when we are computing the p-value for an over table, sorry, or suppose we start with numerator df over denominator df f dot dist dot rt. Let's go back here to do is here to find the p-value here. F no, okay, there f dot dist dot rt, yeah, yeah, and supposed to use degree of freedom, yeah, that's what if I, yeah, sorry, correction please, this is the error that I've noticed from this last formula. It should be 0 0. So we are computing r squared. This is the formula here, r squared, and now we are in adjusted r squared here. So adjusted r squared, we are simply taking 1 minus, put parenthesis, put n minus 1, of which now is 25, and minus 1, oh sorry, and I should make this n minus 1 here. Oh sorry, I didn't put equal sign, it seems. Sorry for that. Yeah, didn't put equal sign. N minus 1 over n minus k. Now case k is equal to 2. N minus k minus 1. Then close here. Then I multiply all of them by 1 minus the r square that I've just calculated here. Here. So getting 0.94 r squared. Yeah. So that's how we are calculating the r squared in adjusted r squared. So the next step, we now want to find the intervals of the slope coefficient and intercept coefficient. So here we have to find a significance level and confidence interval level. So there is a drop down list here and it has nothing. So let's create the values for this drop down list. So here our intervals, we start from, let's create the interval here from significance level usually range from 0.01, 0.01, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.01, 0.02, 0.03, 0.04, 0. No, 0.01, no, should be 0.1, I'm sorry, 0.2, 0.3, 0.0, 0.4, sorry, and 0.05. That's all. So now I want to create a significant level in such a way I will adjust my significant levels and the intercept for both slope, intercept, coefficient of slope and coefficient of intercept will change. So now here I'll just click here because to data, then here data validations, then here fan list, then I'll highlight from here, from here till here. Should also add 0. Yeah, that's all. I click. Now I should again highlight from here to here. Yeah, yeah, but I need to add 0 here. Therefore, now if I click here, there is options here. It's only that my computer is here. Yeah, now if I click here 0.9, you can see, yeah, this is significance level, probability that it will be true. So 1 minus, to find the confidence intervals, subtract significance levels from 1. We are getting confidence interval of 0.9. The most common one is this one, not this one. This one, 25% confidence interval. In fact, it's usually written in percentage times 100. Yeah, I can add this one, can format nicely. Yeah, confidence intervals of 95%. So here, let's calculate the intervals. To find the intervals, we simply add, for example, if we start with intercept first, upper limit, let's edit intercept, upper limit, lower limit, lower intercept limit. That's why, yeah. So let's start. This we are simply uh, we will add or sub to get the upper limit. We will add the estimates of coefficient of intercept. In our case now, it's here, slope intercept. Since it's upper limit, we are adding, then we will multiply the t statistics here by the standard error of coefficient of intercept. In our case here, we calculated here the intercept error here, it's here, yeah. And since but there is something we have not yet done here, to find the t-test tab, to find the t-test critical value, we need a t-test table. But in our case here, we don't have it. We'll use Excel formula. So here we will use a formula known as t.inf here, and this formula take two arguments. The first argument is the significance level or probability, and the second one we take the degree of freedom of mean square error or standard sum of square error, of which it is 25 minus 2, and that is our, where is this one, t.inv, or we should use a formula known as t.inv dot 2t, t.inv dot 2t, where is it here, it's here, t.inv dot 2t, yeah. If I hit enter, I don't know, oh, I've just repeated too many times, that's why. Anyway, enter. Now we're having a critical value of 2.07, but it seems not correct. Something going bad. Oh, yeah, it's correct. It's depend with these values. If I put 0.04, yeah, 2.17. So this is how we calculate the t values. Now this has been computed automatically. To find the lower interval, simply copy this one, enter, then Control V to paste, then here we put subtraction, and we are getting the lower intercept value. The next one, just like the way we have done in the above intercept intervals, we are also doing the coefficient of slope the same way. So here I'll put the slope, upper slope limit level, should be upper limit slope, upper limit slope level, lower limit slope level. These are confident intervals. So here I just take the estimate for the slope coefficient, and it's here. It says 1. It is this one. No, it's the first one, 9.7. Then since it's upper, I'll add. Then I will multiply with standard, with tabulated value, t-test table value. Then I'm multiplying with the standard error. of the slope coefficient, and here it is 0.45. Then if I hit enter, I'm getting the upper limit is 10. I'll find the lower limit, just copy, then I'm pasting here, and then I'll change this one to be subtraction since it's lower limit. Now we are almost done, and if we are just here, want to zoom a little bit. If I just this, you can see that if I increase the value from 0.5, you can see this range is widening. The range become low, the range decreases. But if I decreases the significance level to 0.101, then the range will increase 2 and 9. And if I go to 0, where there will be no significance level, we'll get 0 because it's just a multiple of this one. So putting a lower significant levels increases the confidence intervals but widens the values, widen the range of the values. So the best one is 0.05, which is the center, and we see it as a range of two. Upper limit is 7 and lower limit is -2. So this is how we can compute the confidence interval. So the final stage is to compute the mean square error of the model. So here, mean square error is just a sum of 1 over n, of which 1 over observations here, 1 over 25 times mean square error. Remember, you can compute the residue, absolute residue here, and this is what we got. If we multiply, then let's see what we are getting. We are getting the value of 4.97. This is our mean absolute error. It's called absolute because here when we computed this residue, we put the absolutes here, and we take the total of it and multiply with the number and divide with the number of observations. So next, let's calculate the mean square error. Mean square error. Mean square error is simply we're taking 1 over number of observations, of which in this case we're linking the cells, 1 over 25 times we are multiplying with SSE, 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 this one, sum of square due to error. Then this one, when I hit enter, if you see what we have just get is a 28.8. This is the mean square error. Now let's see. Let's go to the next step, which is root mean square. Root mean square, it means we are finding the square root of mean square error, which is this, the above cell that we have calculated here. Then if we hit enter, we're getting 5.37. This is the mean root mean square error. And this last one is variation inflation factor. This for testing multiple linearity, and this simple because since we have r squared, we are simply taking 1 over 1 minus r squared, value of r squared, which we calculated in the above cell. If I hit enter, we're getting, but it should be 1 over 1 over 1 minus r squared, and we are getting a value of there's something wrong here. It should not be this way. It should be 1 minus, should be here. Here should be 1 minus r. That's so that should be 1 minus 1 over r squared. That's it. Yeah, should be 1 minus 1 over. Yeah, there's something wrong here. Yeah, should be this way. Yeah, this is the variation inflation factor. Yeah, this how it's look. This one is mostly don't use unless when you are testing multiple linearity. So now this is the end of the building of a model, but the last task that we are having is just to test whether our model is working well. So what we will do, we will delete all these data here from here till here, and put another data to test whether this one is working. So there's a new worksheet here called test model, and if I highlight control, then if I click control V to paste, then if I ensure it's matches by deleting the rest here to see whether it's working. Control D. Oh, there's something wrong. Control Z. Control Z. Let's see if there's some problem somewhere here. Yeah, now it's okay. So now if I delete these ones to test whether my model is working and use another data, I had a test data. If I click Control C to copy, then go back to a model, Control, I highlight from the top, Control V to paste, then I ensure it's matched by deleting the rest of the row except the total here, and Control D to delete. Then if I can see here my model is working. Yeah, my model, I can see the model is working. Let's see whether, yeah, so my model is working well, except that here I didn't update it. So here should keep updating because here it's remained fixed. So to update, I'll just link this one equals to intercept. Where is my intercept? This one. I use a dollar equals and sign here ampersand. Then I will link with slope here. Then I add, oh, what's going on? Let me control. See here. Is something wrong here? Here, what am I multiplying with? No, I should not multiply with hard-coded here. I should multiply with b slow intercept, which will be computed here. Then this one here, I should multiply with the slope coefficient here. Where is slope coefficient? Here. Yeah, that's how it should be. So here, I want to paste this one. I don't know why it doesn't not accept my request here. I want to paste here. But instead of that, I'll use equal sign, then take this value here, slope plus coefficient of, oh no, intercept plus slope times x. Yeah, I want these ones, but I will put it as a text. Percent x, that way. That way, I'm wrapping in parentheses. Yeah, that way it almost look well. So I'm formatting it nicely. Now let's see how it's look. Yeah, I put equal sign or ampersand sign here. Equal sign here. Then here ampersand sign here. Then this is how my model look like, but we need to add plus sign this way. Then wrap plus sign with parentheses, put space, then space, and enter. There's something wrong here. Where it is coming from? So here, I put. Oh, I should also put another ampersand. Or I should link this cell with F52. This way. I need to link better slope coefficient. Where is my slope coefficient? Slope coefficient. It's here. It's here. Yeah, that's this how it should look. F551, F548. Then if I drag to apply to all of them, I don't know why it's doing this way. Times it should be x here, that way. And if I drag down too much, let's see what problem might be. Oh, it's moving. So what we forget to do is to lock the cells here. So we should lock everything here. Lock this one with dollar sign, lock this one with dollar sign, lock, lock also this one with a dollar sign. Yeah, this way, then hit enter, then drag to fill down. Yeah, now this is our model. This is how our model work. Now we have successfully created our model. You can see everything changes because we have just put here new data. We have just put a new data and everything now changes. You know, from here we last data we get 365 SF statistics. Now it's 333. Now we have successfully created our model with a new data. We can just go there and copy back our data and see whether we'll have the result that we had last time. So this one take any data as long as it's within the range that you have provided. Then if I click Ctrl V to paste, then everything changes. What you need to ensure is that you need to highlight and fill down, Ctrl D to fill down that way, and our model return what we had last time here. So we have successfully created our model, and guys, thank you for taking your time to watch this video. We have come to the end of this video, and you have learned a lot about the simple linear regression. So thank you guys. Please like, subscribe and share my video. I hope you find it useful. My name is Kelvin Kipsang, and keep watching. We'll meet in the next video, and in the next video I'll be back to Python machine learning, whereby I will take you through lasso and range regression and simple linear regression.